Turn this on when I get ready, so don't let me forget.
Good evening, everyone. It's time for us to begin our third and final
Are you sitting up
session
here? I'll sit
of
over
this
here.
particular
No, it's fine.
lectureship on the great designer. Tonight, Dr. Payne is going to be speaking to us about the immune system. There is a handout that is being circulated. Make sure that you get one of those. And at the appropriate time, Dr. Payne will reference that and the significance of it. Again, we remind you this series of lectures is being brought to you by the Christians that meet at Spring Street in Mount Pleasant. We'd love to have everyone that can join us for our Bible study and our worship hour tomorrow morning, 9 o'clock and then at 10 o'clock. As Dr. Payne will be speaking there on those occasions on Have This Mind, the Mind of Christ, and then at the 10 o'clock hour on Two Disciples, looking from the Gospel of Luke at the two disciples on the road to Emmaus and the significance and power of the resurrection. And now, without any further ado, let's give all the time we can to our dear brother, Dr. H.E. Buddy Payne.
Thank you. All right, folks, I'm going to try to be a little more efficient at this hour, but I get so wrapped up in things that need to be said that I sometimes say more than needs to be said, but you'll forgive me, I hope, because it's so fascinating, incredibly important. And what we're talking about at this last hour in this series, and by the way, this series should be extended for the next 3 weeks. There's a whole lot, there's that much to talk about. I have chosen to give everybody the treatment of your body. I think we're interested in roaches, probably. In Florida, we're interested in roaches, getting rid of them, and other kinds of beasties. But I think we're most interested in ourselves. Where did we come from and what we're about? So what we want to focus on tonight is human beings and the features that cause me to say God is alive when I look at human beings. So there's several features to that we could consider. We'll make an introduction, and then we'll talk about a specific part of our human body, the immune system, which I've been studying in intensity in recent years, but it deserves a whole lot more. So that's what I want to do tonight. Thank you for being a tough audience. You've stuck it out, and you're back. So thank you. It is a great honor to me that you're here. And okay, thank you. And it's my honor that you're here. So thank you. And so tonight our topic is fearfully and wonderfully made. And of course that's a direct quote from a scripture. Everybody probably in this audience knows the Bible teaches that humans were a specific creation distinct from all others. That humans were created according to the scriptures in the image of God, unlike anything else, to have dominion over the natural world and to enact and reproduce, fill the earth and subdue it. Clearly included in that message is responsibility for taking care of it as we tend the natural world. But folks, there's a limit to what we can do in terms of tending the whole world. But certainly we're expected to be generous and careful with what we do. But here's the passage that says that, Psalm 139, and I'm not going to take the time for the sake of time tonight. I'm doing a little constricting of time here. Psalm 139 says we're fearfully and wonderfully made, and that we know right well. So it's a biblical expression that I'm basing this lesson on. And it fits right well with Romans 20, which is kind of being the theme passage, if you're going to look at the Bible, that says the natural world can lead you to believe in God without the Bible. Did you hear that? Independent of the Bible, one can come to be a believer by examining the things that are made. That's the argument from design. That's what we're talking about. So at this lesson, I want to talk about design in us. And again, may I offer an apology by starting? No speaker is supposed to apologize before he starts. But your body deserves an apology from me because I will not have begun to give it proper treatment to truly talk about all the design that's there. Just understand, we'll take one little piece of it and hopefully help you be in awe of God more than ever. So, here we go. We're going to go back to our favorite author, Richard Dawkins, from his book, The Blind Watchmaker, in 1986, to which I've referred previously in this series. I quote Richard Dawkins in case you weren't here for that first lesson, because Richard Dawkins has been appointed at Oxford University in England as the professor of public communication of science. So he's a representative of the scientific community to tell all of us common folk what science is telling us. And folks, this gentleman who has been appointed by Oxford to tell you what to believe has a concept that is firmly founded. Well, let's just talk about it. Here's what he says at the beginning of this book. We animals are the most complicated things in the known universe. Well, thank you. I agree with that. Biology is the study of complicated things that give the appearance of having been designed for a purpose. At the beginning of a book called The Blind Watchmaker, he says, when you look at us, it sure looks like we were designed for a purpose. And so he spends 300 pages trying to convince you, but no, you were not. The process by which an airliner came into existence is not fundamentally mysterious to us, because humans built it. Would you say amen to that? What about our own bodies? Each of us is a machine like an airliner, only much more complicated. Agreed? Were we designed on a drawing board too, or were our parts assembled by a skilled engineer? The answer is no. You see? Is that reasonable? It sure doesn't look like it. But Mr. Dawkins would tell you, you're just using your common sense, and sometimes your common sense doesn't make sense. Well, I would say to you, sometimes your sense doesn't make any sense at all. We shall explain its coming into existence, that is, you, as a consequence of gradual, cumulative, step-by-step transformations from simpler things, from primordial objects sufficiently simple to have come into being by chance. Now let me explain that to you another way. Here's what Richard Dawkins, Dr. Dawkins, would tell you. Any complicated thing, of which you're the most complicated thing there is, can be broken down into simpler things. And every time you say, well, that's not simple enough to have happened by natural causes, then break it down more, he'd say. And so you break it down more, and you say, what, can we stop there? No, that's still too complicated, we would say. So, okay, then break it down into simpler steps. And he would say, you just keep going until it's simple enough that it could have happened by natural causes, and those things add up over time gradually to make you. And every other thing that's alive. Without any creator, there's no designer, and there's zero purpose for you. Because why would there be? If you're just the result of a natural process that didn't have you in mind. He calls it the blind watchmaker, folks. Natural selection acting upon natural variation has no purpose. And look, let me tell you something. If you're going to accept the evolutionary worldview, you need to accept it all the way. And when you accept it all the way, it means you have no more purpose than a bacterium. In fact, folks, they're tougher than you are. And roaches have been around a long time too. And why should you be any better? And what are you doing stepping on a roach? That's a living thing. It's been around a long time. Why do you think you're any better than a roach? And if you take the evolutionary viewpoint, why would you be? And Darwin's book, if I may remind you, said the salvation or the preservation of favored species. You remember that? If there's no purpose and no design, then just a roughshod nature is going to run over things that aren't the best species and destroy them. And have humans tried to do that through the centuries? I will tell you they've tried to do it more in the last centuries than ever in the history of mankind by atheistic regimes. I frankly don't want to go there for all kinds of reasons, but I do not believe the examination of the natural world supports such a worldview. So I'm going to ask you, jury, when we get finished tonight, can you honestly believe that cumulative step-by-step transformations over millions of years from simple primordial things just came about by natural causes, the blind forces of physics acted upon by natural selection? Can you really believe that? That's the question. So let's take a little more careful look. And I love Michael Behe's book, Darwin's Black Box, of which there's two versions. You need to get the later one if you're going to get it. Darwin's Black Box. It's well worth your read if you haven't read it. Dawkins can simplify to his heart's content because he wants to convince his readers that Darwinian evolution is a breeze. In order to understand the barriers to evolution, we have to bite the bullet of complexity. Now, may I explain something to you about Dr. Behe? He's a biochemist, and religiously he is declared as a Roman Catholic. I'm only mentioning that just to tell you a little bit about him. If you're not aware, the Roman Catholic Church has publicly declared the acceptance of the general theory of evolution as an explanation. He had no reason as a Roman Catholic religiously to deny the general theory of evolution. But Mr. Behe has come to be an unbeliever in the theory of evolution, if you mean the general theory, that all living things came from a common ancestry by this common process I just told you about. He doesn't believe that for a minute. And why doesn't he? Because of his chemistry that he studied. He says Dawkins can simplify all the way he wants, but the complexity of even the simplest things is like another Grand Canyon that you have to cross. Even the simplest things. Biochemistry has demonstrated that any biological apparatus involving more than one cell, such as an organ or a tissue, is necessarily an intricate web of many different identifiable systems of horrendous complexity. Have I shown you that a little bit, class? So I want to refer you to this little book called What Darwin Didn't Know about Jeffrey Simmons. It's worth your read. Jeffrey Simmons was an evolutionist all during college, during medical school, and during the early part of his medical career, till he started doing all medical practice on people and examining the way the body really works and opening up his eyes. So here's what he says now. I'll just take the one example. Let's look at a couple of examples. The interior of the human body is a much busier place than New York City, London, Mexico City, Tokyo, and Bombay combined. You have trillions of cells in your body. Some say 17, some say 50, some say 30. There's a difference of views on how many you have. But it's trillions, folks. That's a lot. That's more than our government can spend. No, it isn't anymore. That's right. I'm sorry. That's a mistake. Take that back. Strike it from the record. That participate in more than a quadrillion purposeful chemical interactions each day to help us walk, breathe, think, sleep, and you fill in the blank. He goes on for a whole paragraph. The human brain is an extraordinary multitasking, multi-purpose biological computer. With capabilities, it can store 100 trillion to 280 quintillion bits of information in a 3-pound piece of matter. It's protected by bony armor, cushioned by fluid, serviced by a complex network of blood vessels, and everything about it exemplifies purpose and design. Look, you study the human brain, you come to a conclusion, somebody designed that. Every bodily action is coordinated by conference calls between millions of neurons in the brain. Imagine a multinational corporation with 35 billion employees who stay in constant touch with each other and are capable of making trillions of decisions every microsecond. And you got a sum up idea of what your brain does. Every aspect of human physiology has multiple facets, steps, purposes, managers, feedback loops, anticipated outcomes, and double checks. Every function is too complex to have been formed by slow, accidental changes that fit together luckily over time. Dr. Simmons would tell you, as a medical doctor, there is no way this happened by small changes over long periods of time guided by natural selection. Did not happen. It's a myth, ladies and gentlemen, propounded by Richard Dawkins and his ilk, who believe it with all their hearts. I've had lots of interactions with folks like that, and I've never found, in my experience, more closed-minded people than those who are so convinced in the general theory of evolution. They cannot see, and it's a shame. Don't be like that. You don't have to agree with me, but open your minds and examine the evidence. So I want to talk tonight about one aspect of humanity that's fearfully and wonderfully made, and that's our immune system. Has the immune system been on our conversation of late? Listen, with the advent of COVID-19 and all the things going on with that, the immune system is headline news. So that's why I want to talk to you about it. So what I have chosen to do is read a new book recommended to me by scientists. This is not written by a scientist. It's written by Philipp Dettmer, the creator of Kurzgesagt website. His goal in life has come to be explaining complicated scientific things to average folks. So he took on the immune system as a project in college, and it took him a year and a half to even get to a place where he could start explaining things. And this book, Immunity, or the Immune System, A Journey into the Mysterious System That Keeps You Alive, by Philipp Dettmer. You need to read this book. It's a little heavy, but you can skip the hard parts and still get the point. And by the way, he's a comedian. He's funny. I've been reading this in my office, and Marilyn, my sweetheart, would walk in on me every now and then just laughing out loud because the guy's hilarious. So I want to help you laugh a little bit this evening. So let's start at the very beginning. I'm reading from the introduction class. Imagine waking up tomorrow feeling a bit under the weather. An annoying pain in your throat, your nose is runny, and you cough a bit. By the way, the moderator who speaks this on the video I'm going to show you is British. So I may impose a bit of British every now and then. All in all, not bad enough to skip work, you think, as you step into the shower pretty annoyed about how hard your life is. While you're totally being a whiny little baby, your immune system is not complaining. It is busy keeping you alive so you can whine another day. And so, while intruders roam your body, killing hundreds of thousands of your cells, your immune system is organizing complex defenses, communicating over vast distances, activating intricate defense networks, and dishing out a swift death to millions, if not billions, of your enemies. All while you're standing in the shower mightily annoyed. But this complexity is largely hidden, which is a real shame because there are not many things that have such a crucial impact on the quality of your life as your immune system. It is all-embracing and all-encompassing, protecting you from bothersome nuisances like the common cold and scratches and cuts, to life-threatening stuff like cancer and pneumonia and deadly infections like COVID-19. Your immune system is indispensable to as your heart and your lungs, and actually it's one of the largest and most widespread organ systems throughout your body, although we don't tend to think about it in these terms. How much attention have you given to your immune system? It's why you're alive, ladies and gentlemen. And it's busy all the time. So this is in the introduction. I'll refer you to it a little later. The immune system is very complicated. Although that's not a strong enough word, so he's kind of sarcastic here. The immune system is complicated in the sense that climbing Mount Everest is a nice stroll through nature. Did you get that? It is intuitive, like reading the Chinese translation of the tax code of Germany as a fun Sunday afternoon exercise. The immune system is the most complex biological system known to humanity other than the human brain. And we're going to take it on, class. But it's amazing. So, with the help of Mr. Detmer and by the way, he's made some magnificent visuals. And may I tell you, this book is evolutionary from beginning to end. He talks about all this amazing stuff, and then he talks about how Mother Nature produced it over millions of years. It's beyond belief. They really believe this stuff, while they're at the same time talking about the immensity and the magnificence of these designed things which aren't designed. And here's what Mr. Behe has to say about it. So you got that piece of paper with you? Please take it out right now and get your pen out. I want you to write down these 4 words, because you're not going to remember most of what I say, but I want you to remember a few things. So Behe says, here are characteristics of the immune system. Diversity. Write it down, please. Diversity. Your immune system is critical, and it has to produce diversity. We want to talk about that a little bit. Secondly, it has to provide recognition. The big point there is, class, an immune system, yours, needs to recognize what is you and what is not you. Because you don't want your immune system attacking you. Because folks, in case you don't know it, your immune system is the most dangerous thing you have. It can kill you in 15 minutes if it starts attacking you. You don't want that. So you want a system designed, did I say that word? So that it recognizes the difference between you and other. Thirdly, destruction. Your immune system better be able to destroy things. And there's a new word I'm going to introduce to you. Apoptosis. Write it down. See if you can spell it. I'm going to say it to you. Listen closely and spell it. Apoptosis. Okay, who wants to spell it for me? It's not hard. This one spells like it sounds. Okay, A, good. That's the first letter. How about pop? P-O-P-T-O-S-I-S. Apoptosis. So what does it mean? Anybody know? Huh? Cell death. It means killing yourself. Part of your immune system is to make cells kill themselves. You're going to hear it over and over again. Apoptosis. It sounds like a very innocuous word, but it's death. Cell death. All right? Got to have destruction in an immune system because you got lots of enemies. Fourthly, toleration. Your immune system has to put up with some stuff. Your immune system in your intestines is quite different from your immune system floating around in your blood all over your body. In your lungs, the immune system's quite different. It's more sensitive. You can't have it blowing up stuff in your lungs. It'll kill you. So in case you didn't know it, the immune system in different parts of your body functions differently. Looks like a plan to me, folks. Every place you look, it's designed for that place. So toleration is critically important. If it didn't have that, you'd be dead. So every one of these is critical to the functioning of the immune system. Look at what he says. All of these and more interact with each other. Whichever way we turn, a gradualistic account of the immune system is blocked by multiple interwoven requirements. If you don't remember anything else, you remember that. Everything in your immune system is all interwoven. And every piece depends on every other piece. So how do you get that going one step at a time? Just narrow it all down to little steps and then it all adds up to something. No, folks, you got to have it working properly, interwoven, or it doesn't work. As scientists, we yearn to understand how this magnificent mechanism came to be. But the complexity of the system's dooms all Darwinian explanations to frustration. You see, it's in the details that Darwin loses every time. You get down to the complexity of the details, and it has to give up. Because one of the things Behe says in Darwin's Black Box is there is a chasm between even the simplest thing from one to another. It's like it's not a little leap. It's a Grand Canyon everywhere you look. Now, that's the paper you have in your hand, right? Let's walk through it together. I want to, first of all, do the outline of the big picture. So everybody look at your piece of paper, and it's what I have up here. I'm going to blow it up just a little bit, so hopefully you can see it better, but you've got it in front of you anyway. Here's the anatomical and physiological barriers. Well, I wish we had time to talk about them. I'm going to take just a few seconds. The skin is your most important protection. Do you know it's the largest organ of your body? It's all over you, and if you didn't have it, you'd be dead in minutes, because it's your protection. But one of the problems with the skin is it has lots of holes in it, like, and other places to which I will not point. You have holes in your skin, places where things can enter that are not going through your skin. And by the way, all of those places that enter your body are really outside your body. Have you thought about that? I mean, the inside, as you let things go in your mouth and all the way through to your gut and out, where they go out, that's really part of the outside in a lot of ways. So your body has a system covering all that called mucous membranes that help. And that's listed up here, I think, too. And it doesn't say that. But then as you've got ciliary clearance, you remember I talked to you about cilia a while ago? You got hairs all over the place. And they help you. They help protect you. And then you've got low pH in your stomach. Your stomach's pretty heavy with acid, which is a good thing because it kills stuff. And then your lysosomes and your tears and your saliva, as soon as you enter something here, you got proteins acting on it to kill stuff. And we haven't gone anywhere near where we should go with that, but that's your first line of defense. But what happens if you break the skin and something starts getting inside of you, or if it gets in your lungs and it gets through the very thin filter of your lungs and starts working on your lungs? You've got trouble in River City. But here comes the big parts. You've got two parts, the innate system and the adaptive. And that's your immune system put together in a nutshell. And let me explain to you. First of all, I want to read them to give them honor, okay? Innate system has eosinophils, natural killer cells, neutrophils, macrophages, mast cells, and dendritic cells, and natural killer T cells. All parts of your innate system. Down here you've got the complement in the humoral part, the mannose binding lectin, antimicrobial peptides, LPS binding proteins, and C-reactive proteins. There's a bunch of stuff in the innate immune system that is critically important to you. We don't have time to talk about all of them, but we'll teach some. And then in the adaptive side, the main components are T cells and B cells. And the B cells make antibodies, which float around in your bloodstream, about which we need to say some things. And those make up your adaptive immune system. So let's look at the big picture now. So first of all, the innate immune system is very important because it is fast in response. As soon as you've got an invader, macrophages are after him. We'll talk a little more about that. And neutrophils, that this man says are like monkeys on coke that are upset and carrying a machine gun. So that's neutrophils. I mean, they're your wild bummers. They're going to kill whatever they see. But they're acting quickly. It's fast response. Instantly, as soon as you're like you cut yourself, these guys go into action. And it's non-specific. They're not after particular enemies. They're after anybody that's an enemy. So all they need to know, it's not you. And if it's not you, we're getting you. Life is too precious. We're going to kill you fast. And the more we can kill you, the better it is. I mean, if I get mean about this, it's too bad. Because if you don't get mean, you're dead. So all of these guys go into action fast. One of the problems, though, is they produce no memory. The innate system does not have any memory. In other words, it kills you and just forgets it. Or better, it kills itself. You know what neutrophils do? They're killing machines. They're out to kill everything. So their lifespan is very short. They know good and well they got a short time, so they just go around killing stuff, and then they kill themselves. They blow up. And by the way, in the process of blowing up, they kill more stuff. But what is blowing yourself up? Apoptosis. Neutrophils are expert at apoptosis. Nobody has to command them to kill themselves. They know death is coming and they just do it. But here's the main features of the innate system. It's fast, non-specific, and provides no memory. That's why it's not good enough. Because in many cases with really bad enemies, this system is not going to keep you alive. So it knows very well it's got to activate the adaptive system, because that's where the big artillery comes from. So here we go. What about the adaptive system? It is primed, and thus it's slower. It's not going to act unless it's primed. So how does it get primed? Well, one way is dendritic cells right here are like your intelligence arm of the Army. They gather information. They go over here to the T and B cells and they say, look guys, it's time to get to work. So the dendritic cells are kind of on both sides. They make the T and B cells get activated, which start doing things to help the system kill. All right? Secondly, they are specific. T and B cells come in the billions, and every one is unique. You listening to me? One of the things he says about that particular system, both T and B cells are made in your backbone, in your bone marrow, and they are made by the millions and billions, and every one is unique for a specific enemy. It took us years to figure that out. But we now know that your body produces enough. He calls it the largest library of information in the universe. The way we build T and B cells. It's massive. And what he argues is, any enemy you will ever face in your entire life, no matter where you live, even if one day we go to Mars and meet creatures we've never seen, your immune system will have something in it to kill them too. Because they make them by the billions and everyone's unique. Is that incredible? Well, that's the way it is. And then the amazing thing is, with the adaptive immune system, they produce memory cells. Both T cells and B cells produce memory cells. You know what that means, class? That means once you've had a disease and that B or T cell was attacking that disease, there are cells left in your body from then on for the rest of your life that know that enemy, that specific one. And if he ever shows up again, what happens is those memory cells activate your immune system instantly, kind of like the innate system, and do not have to go through all those intermediate steps. It may take days for your adaptive immunity system to get going, but not if you've had that enemy before. Then it'll take seconds, because they don't have to go through the intermediate steps. That's why older people who've had lots of diseases during their life are better at fighting the same diseases than kids. And little bitty kids don't have much of an immune system. You know that, right? When you're born, your immune system needed help. And your mama gave it help, especially if she breastfed you. Because coming out of her womb, she gives you part of her system to help keep you alive. And her breast milk gives you a whole lot of other stuff from her immune system to keep you alive as a baby. We're missing out, ladies and gentlemen, when we try to do things artificially. I know some cases women can't do it, but if you can possibly do it, breastfeed your child, because you're enforcing their immune system as well as loving them and taking care of them and nurturing them and blessing their lives. But on this lecture, we're talking about immunity. Your immune system grows as you get older because it has memory. All right, let's see now. Okay, we're going to take one of Mr. Detmer's videos. And his British moderator is wonderful, but he talks about how in millions of the years this happened. Every time you turn around, I'm sick of hearing it. So I will be the moderator, but I'm going to use his stuff and say it exactly opposite of what he says. Same information, different interpretation. So here we go, class. Are you ready? Anybody getting sleepy? I don't allow it. Okay, I need you alert because we're going to introduce you to the immune system. Here we go. First of all, you see the top there? Pathogens. Pathogens. Those are guys that are your enemies. There's all kinds of them. Things that cause you problems. Pathogens are attacking you all the time, and you've got an army to help you get rid of them, and we'll talk about some of this. So let's go. Are you back? Ready back there? Go! Here are the pathogens, and we're going to introduce you. See this whole thing, once this all gets up, stop. Ugh. You got to go back. We missed it by a microsecond. All right, start again, and be sure you stop precisely when I tell you to. Stop. One more time. Go. Stop. Perfect. Thank you. All right, do you notice, class, that over here we have the innate system and over here we have the adaptive system? And in it we have all those different parts I told you about. Chimps on coke carrying machine guns, macrophages, complement dendritic, and so on. And all the B and T cells and all that they do over here. But here's what I want you to see in this video. Do you see all the lines connecting everything? It's an illustration, and it's a good one, to show you that all the parts depend on every other part. Don't forget that. Your immune system builds on one another or it wouldn't be functioning properly. Now, here's my first question then, ladies and gentlemen of the jury. Look at that system. Do you think that part of that evolved? Just take the little T cell piece, and that evolved by itself somehow over here, and then somehow over time it got connected to this one, and then connected to that one, and then over time it started working. No! There's no way. This was designed to work together. That is the most reasonable explanation. Okay, let's go on now. And here you are with your lymph node system. Stop right there. Because your body not only... I hit the wrong button. I'm so sorry. Get me back. There. And I've got to hit the right button. Your immune system not only has the bloodstream, but it's got a whole lymph system flowing through your body. You know almost nothing about that. You learn it though, don't you? If you're a nurse especially, right? But one of the two major organs of your lymph system are the thymus, which sits right in there near your neck, and the spleen, which sits right down here. Those two organs we could talk about a long time, but I'll tell you in advance, this one is critically important for all the T and B cells because it provides a university for them. Every T and B cell have to grow up and they have to go through university. And they have to pass the tests. And I'm going to tell you about that a little more in a minute. or they can't become T and B cells in your body till they pass the university. And that's the thymus gland. And we'll come back to that. All right, keep going. So there's the vessels are all over your body, and look, he's looking around saying, look at all this. Stop! First part of your army, class. What this guy likes to do is make them look like little creatures. You know they don't look like that. But he wants to make them come alive for you, okay? So these are the biggest guys in your army for the innate immune system. They're called macrophages. Macro means big, and what do you think phage means? Eat. They're big eaters. They're big and they eat a lot of stuff. They're a huge death machine. And by the way, they also clean up the garbage. When there's a bunch of dead cells and junk lying around, the macrophages come around and chew them up better, spit them out, and recycle them. Critically important. Go. Stop. The pink guys, those are the dendritic cells. That's your intelligence army, your intelligence core of your army. They gather information and share it. Plus they do a lot of other things. They also kill stuff, but they gather stuff and spread the news. And especially they activate the adaptive system. Next, the little guys. See them coming in here? Keep going now. Go. Stop. These guys are your helper T cells. They're like your colonels, middle management. They do all kinds of things. They help other people do better, and they do lots of other stuff, as you will see. And then these are your B cells, which are very important in your system for big things that need to be done. And the biggest thing is they make antibodies by the billions once they're activated. And then finally, go ahead, stop. You have the neophils, and remember I told them they're like monkeys on coke with machine guns and in a bad mood. They're your bomber killers. Welcome to your army, class. Next, keep going. So here you go, you're out in the world, surrounded by enemies. You don't stand a chance against internal enemies like cancer cells, which are your own cells acting up badly, and external enemies. You're in trouble when you cut your thumb. You see that? And he goes, stop. You cut your thumb. Big deal. Not a big deal to him because he's going to put a Band-Aid on it and go right on about his business, right? It's a humongous deal to what's going on inside. Because look, you have decimated a part of your skin. And you've opened it up to enemies. So watch. Millions have access now to your inside. And so here they come, looking around in this nice warm environment. Look, this is a pretty neat place. And so they're looking around, where can I have more babies and leave stuff behind? He says they go pooping everywhere, and it's making a mess. And there's lots of cells in here that in the course of getting cut or getting damaged, these guys got damaged, you see, and they start screaming, stop, stop. They're screaming. In chemistry, that's called cytokines. They're giving off chemical signals. Help! Come on! Where are you guys? We need help. They're killing us. And seriously, they're sending out chemical messages by the droves. And the first ones to answer, keep going, are the macrophages, these humongous eaters. And stop right there, because now we're going to talk to you a little bit about macrophages and how big they are. If you compare a normal cell to a human, then the macrophage, go ahead, is like a rhino. And he can get mad. You don't want to mess with a mad rhino. And that's what happens to the macrophage when you stimulate him. He goes after him. He sucks them in, takes them inside, puts them in a vacuole, showers them with acids, chews them up, and spits them out. And he can kill 100 of those in a microsecond. I mean, you see those tentacles? Burp. And I'm full. I've already eaten 100 of them. Stop right there. So they send out more. What do you think? Cytokines. More signals. And they bring in the neutrophils, the wild bombers, like monkeys with Coke and a machine gun. And they come filtering through the system, and here they come. Kids, is this fun? This is better than Star Wars. Keep going. Here they come. They're coming to the rescue. Here comes one. See, they eat up stuff too. They take it inside, chew it up, and spit it out. And they come over here, and this cell says, stop, stop, you're about to kill me. So he apoptosises, if that's a word. That was close. He almost killed the cell. Well, they're still going around eating things and blowing up and blowing stuff out. They have all kinds of ways they can kill things, and they know their lifespan is very short, because if they keep doing this, they're going to destroy you. And they do. They kill cells, and they don't care. They're just killing stuff. So eventually, they're going to do this. This guy's guts blew out of him. And by the way, that kills a bunch of stuff. And look at this guy. I mean, he's basically dead, but watch. I'm not dead yet, guys. I'm going to kill some more. Die! So did I get it across? All right. These guys are your first line of defense, and they're out there working their hearts out to keep you alive. And many of them dying because of you. And most of them have to die anyway, because if they kept working, you'd be dead anyway. All right, so they call on a helper, guys. These are called the complement system. Stop right there for just a second. The complement system is so complicated, it takes me 2 days to explain it. So I can't take the time. Here's what you need to know. The complement system is supplementary to all these other guys. It's a whole bunch of proteins. Do you believe it? Proteins that are helping kill things. They come flood the cut site. When all that blood comes flowing in, they come with it. And they start surrounding enemies. And the complement system is a complex, balanced chemical set of equations, which I hope I can explain to you a little more later, but just in case we don't have time. They do all this, and it's all balanced, because if it happened all at once, you'd be dead. But everything has to be kept in balance and only activated when it's the right time. And finally, when they get finished and they do all their work, they blow you up. But it's a bunch of different chemicals, all proteins, working on your body. Keep going. So here we've got the guys still working away, trying to kill all these enemies. And it's not enough. You know, you just get tired, and so you turn purple. Whoops. I did it again. See, now he's got to get me back to where we were. Is that good or what? This guy's wonderful. All right, that's too far. Good for you. You need to hug this guy later, because I keep hitting the wrong button. All right, so here we are back. Now go. So they're getting tired. So they turn purple. No, they don't, but it makes them look tired. So they call for more help. And the dendritic cells, okay, I got to get to work. So he takes in an enemy, chews him up, makes him into pieces, and spreads him all over his body. You see that? The dendritic cell has got parts of the enemy spread all over his little tentacles there. It's like he put his guts all over him. That's not very nice. But you know why he had to do that? Because T cells and B cells only recognize certain enemies if you've got them kind of stuck out there. So he's looking for the specific T cell for that enemy. And there's millions of them, so how in the world are you going to find that one? Well, he goes looking around through your cell system. Pause right there just a minute. Did you know, ladies and gentlemen, that in your lymph system there are places where T cells sit down and have a cup of coffee? Not really, but there are gathering places for T cells. And your T cells are cycling through your lymph system all the time. It's like they're traveling over the entire United States every single day, stopping at key places to take a rest. So the dendritic cells stop at those key places and start testing T cells. and say, is this the one for this particular enemy? So let's watch. Here we go. Is this the one? No, not that one. Nah. Not that one. No. Oh, that is the guy. Stop right there. There's the pathogen, or the antigen as they call it in this case. It's a piece of the pathogen that is exactly the fit for that particular T cell. You see that? Class, your body makes billions of these, and they each have a specific activation site that's for a specific enemy. This is the one for this particular enemy. So this guy says, I have found the T cell of T cells. Now be careful with your thing back there and be ready. Keep going. So you go back out and you see there's love at first sight. You see that? I love you. Stop! We missed it. Can you go back just a little? Yeah. When he joins together, will you stop just as soon as they join? Try it. Go, stop! That is marriage. Mwah. They just kissed. Folks, the innate system of your immune system has just kissed the adaptive system. The dendritic cell has activated that particular T cell because that's what's needed. So, once they've kissed, they're now married. Officially, and it's okay. So here we go. And so the dendritic cells, okay, we're married. Now will you wake up? It's like a recalcitrant teenager. Wake up! Get moving! Okay, so he gets activated, and now he starts dividing. Aha, 1 becomes 2. 2 becomes 4. Why is that important? Because each one of these is for that specific enemy. And so it starts multiplying and multiplying until it's in the thousands, and about half of those guys start heading for the cut scene, and the other half go looking for T and B cells further. And so here they come, and this macrophage is worn out. You remember? He's already eaten a bunch. He's burping and sick and tired of it all. And he's worn out. So the helper T cells come alive, and they come around him and say, I'm going to touch you, and say, will you wake up? Wake up, and give him a little piece of chemistry. There's a reason you're here, fellow. Get angry! So he turns red. No, he doesn't, but he gets angry. And he starts after, Rawr! And he starts killing like a wild maniac. And they do the same thing with the neutrophils as if they needed it. But helper T cells are helping. And now the other guys have gone looking for B cells that are needed now because you need more help, and they've got to find exactly the right B cell. And so there he is, and there's marriage. I love you, B cell. And then the B cells come out and start activating, and a bunch of them turn into machines that make antibodies at the rate of, stop, millions per second. And they flood your whole bloodstream with antibodies. But what antibodies, class? What do you think? For that specific enemy. Prior to that, your stem cells are making B cells that'll kill a specific enemy, but only a few of them. But once that guy identifies the enemies in your body, he makes that particular antibody by the millions and floods your system. Whew. Let's go on. Oh, wait a minute, right here. So you're a human. You're back here and you're looking at your thing. Oh, things are getting kind of better. Well, it's been a day or two, and you're activating your adaptive system, and now big things are starting to happen. And by the way, can I take just a minute here, class? Because we haven't said one thing about blood clotting, have we? Blood clotting is not your immune system. That's another whole complex set of chemistry. And if we had time to tell you about it, there's a complex cascade of chemical reactions to make this thing clot up and close the wound. And you know that clotting is your best friend and your worst enemy? What do people die from the most? Heart attacks and strokes, both of which are clots. where they don't belong. Folks, when you cut your finger, it needs to clot right there for a certain amount of time and then stop clotting, or you'll kill yourself. That's another whole chemical set that I haven't even talked to you about. And it is so complicated. Every little step is necessary. Are there people who have trouble clotting? What are they called? Hemophiliacs. You know why? Because there's one piece of that whole concave step of reactions that doesn't work. And so your blood doesn't clot. Are you listening to me? One step out of 20 doesn't work and nothing works. So that sounds like Dawkins, doesn't it? Yeah, that just happened by small steps. So he said, just simplify it more. You can't. It doesn't work. But will he admit that? No, sir. But let's go on with the immune system. This guy's getting happy because it's clotting and the system's killing all the enemies and it's getting better and it's not a big deal. He just got a cut. But what you don't know is there's billions of people, things that have lost their lives because of your stupidity. All right, here we go. The antibodies have surrounded them and made it ready to attack, and so they helped them kill it. Then here are some more T cells right here, and they go to the side and watch. They turn into memory cells. And look, they're looking around. See them? I'm looking. Is that enemy anywhere else? They're looking right there. Boo, that's the guy. Get him! And B cells make memory cells that will, from the rest of your life, start making antibodies instantaneously if they ever see that enemy again, without going through that process. And so for the rest of your life, you're protected from that enemy. So don't talk to me about vaccines versus our natural immune system. There is nothing to touch our immune system. And may I give a personal testimony? I got COVID-19, got pretty sick because it attacked my heart. I have a weakness in my heart. I think COVID goes to your weakest place. But I got really sick, and I got over it. So I told my doc, my heart doc, who, by the way, listens to me. Do you have a doctor that actually listens? It's kind of nice. This guy's almost my age, so he really listens. And we sit at a computer together, and he explains all this stuff to me. And I said, Doc, I want you to test my antibodies for the next 3 years. Every 6 months. In fact, I want it done every 3 months. And he's getting it done for me without costing me anything. He's a nice guy. But I have tested. It's now been 2 years since I had COVID. The last time I was tested was just a little while ago. He said, you are eaten up with antibodies for COVID-19. Eaten up with it. Don't talk to me about 9 months. That's not the way your system works. You have memory cells once you've had it for the rest of your life. The natural system is 1,000 times better than any vaccine. Now, does that mean I want you to get sick? No, not preferred. And I'm for vaccines when they work properly. And we've had them. Polio has about been destroyed in the face of the earth. Measles, very important. Did you know there are lots of folks stopping vaccinating kids for measles? And it's coming back. And it's a terrible disease. Let me tell you something. Measles, one of the things they do for you is they kill memory cells. Are you listening? You don't want measles. It's one of the most dangerous diseases ever had. And it's been basically eliminated by vaccinations. And people are so against vaccinations now, they're stopping vaccinating for measles. Please don't do that. Because it's going to hurt the rest of the population of the world. And measles do deadly things to you, not just, even if you get over them, they've killed a lot of your memory cells and you'll never get them back. So don't do that. All right, that's the end of that one, isn't it? All right. How much, are you hanging in there? Recognition. Enzymes, macrophages, killer T cells, and antibodies. We've talked about most of that already. And the enzyme, and here's a antibody. You probably don't know much about antibodies, but they look like a Y shape. Every antibody has a heavy chain and 2 heavy chains and 2 light chains, and these are the binding sites. These are the specific sites that attack a particular enemy. And they are made by B cells. And so the B cells comes with a built-in antibody, and once that antibody finds a particular enemy, then here's what happens. Well, I'm going to tell you now. In your cells, your stem cells build B cells and T cells, and they build a whole bunch of different kinds automatically. And once this particular kind sees an enemy that fits, he starts building antibodies for that enemy. This one builds antibodies for that enemy, and this one for that enemy. But that's the way it works. But how do you get all these different antibodies in the first place? Over here. Here's how. I'll let you look at that for a minute, and I know you'll fully understand it. Class, if you were in my class, we'd spend days on this. Your DNA has the capacity to pick and choose parts of the DNA. We didn't learn this till about 15 years ago. So for this particular heavy chain, you can take 1, 2, 3, 4, 5, 6, 7 different sections of the DNA, and you can mix and mingle. And so from that, you can get 65 times 27 times 6, 10,530 types of antibodies just from the heavy chain by mixing and mingling parts of your DNA. And your body does it automatically. But the antibody also has short chains. So for the light chains, there are 4 regions here and 1 there, so there's 5 to pick from, so you can get 40 times 5 or 200 types from the small chains. But you got to have both, a heavy chain and a small chain to get a real chain. So 10,530 times 200 is 2,106,000 types. Plus, there's another couple of factors that makes that into billions. Did I wake you up? Your DNA guides your stem cells to produce that many different kinds of T cells and B cells automatically. It's the largest library in the world. And your cells are doing it all the time. And then there's got to be destruction. Well, you can imagine this is a whole section. I want to really talk about cytotoxic T cells. These guys, they're killers. You take a regular T cell, and you make it mature, and it becomes an activated cytotoxic T cell, which takes a hold of any cell that's doing bad things, and it says to this, kill yourself. Boom! And it does it. Now, what's bad about that, class, is if a T cell tells a good cell to kill itself, then you start dying. So it's got to know which ones to kill. So, class, every T cell and every B cell has to go to school. And I'm getting my book out again. I love this guy. Philip Detmer, page 111. As you can imagine, the body takes this issue extremely seriously and came up with Murder University of the Thymus. It addresses it, and he says over millions of the years this evolved. That's ridiculous. After a fresh young T cell has been born, it travels through the immune system or through the lymph system to the university in the thymus and begins its training, which consists of 3 steps, or better yet, 3 tests. The first test is basically just making sure the T cells have the ability to make working T cell receptors. If this were a regular school, this would be teachers checking if the students have all their notebooks, the required reading material with them, so they're properly prepared. Only they would not send the students home in the university. If they forget something, they shoot them in the face. and you have a dead T cell. That's test number one. The T cell that passes this test can then have functional receptors. Great job so far. The second test is called positive selection. Here the teacher cells check to see if T cells are really good at recognizing the receptors of the cells they will need to work with. Is that important? If a T cell's got to work with another one, he needs to recognize it positively and say, that's my friend, right? Imagine this part as if the teacher is checking if the pens the students brought are full of ink and that the workbooks are in fine condition. Once again, if that's not correct, what do you think? It takes them outside and shoots them. You failed the second test, you're dead. Kids, would you like to be in that school? No. After the first two hurdles have been taken, the last and most important test waits for our T cell students. It's called negative selection. And this might be the hardest test of all. The final exam is simply, can the T cell recognize self? You don't want to release T cells that don't know self, because that means they'll kill you. This is a part of the toleration as well as the destruction system. So here's what happens. The final exam, T cells are presented with all sorts of protein combinations that are used in the cells in your body. Listen, this is amazing, folks. The thymus pulls in chemicals from your body that your body normally uses and makes every T cell react to it. And if you react to that in such a way that you might kill it, guess what? You're dead. You failed test 3. If you can't recognize self and know you better not kill that, then you're dead. So the answer in every case, after it pulls stuff from your liver, your pancreas, every part of your body, the thymus makes this test. It's like making a final exam for everything you're going to have to face. And you better answer it, no, not at all, or you're dead. The teacher cells in the thymus that do the testing have a special license to make all sorts of special proteins that usually are made only in the organs like the heart, the pancreas, the liver, and the hormones like insulin. The thymus can make all of those, even though it's not supposed to be doing that, to let every T cell be tested. If a T cell is able to recognize any of these self proteins, they are taken out and shot in the head immediately. So, one of the things your immune system has built in is Murder University that protects you from anything in T and B cells that would kill you. And you can seriously think with Richard Dawkins, isn't it amazing what Mother Nature did by natural selection, acting upon small variations of things that happen by random chance happenings over millions of years? I hope you see the utter ridiculousness of a theory that has taken over the universities. And there's the complement system. I don't have time to talk about that. Look at the complexity of that. There's 3 pathways to get there. Every one of them is building on somebody else and something else, and everyone's balanced until you get to the very end and it blows the thing up. Let's talk about it just briefly. Go. You wake up back there? I didn't give him enough warning. This is a whole series. Stop! Thank you. Can you count how many are up there? It's 4 by 8. What is that? 32. There are 32 different proteins in the complement system. They're all little tiny proteins. Every one of them made by the method I showed you in the last lecture. Remember that? Your body's making these by the billions all the time. Your body's flooded with them. Keep going on your video. And when it gets to that big number, you stop. Stop. I want you to help me, tell me what that number is. Let's do it. That's the thousands place, right? That's the what? Millions, billions, trillions, quadrillions, 15 quintillion. That's how many complement proteins are floating around in your bloodstream at all times. 15 quintillion. So class, you cut your finger, after a period of relatively short time, your bloodstream starts flowing there more, doesn't it? And it gets all puffy and, and it starts closing up. And the complement system floods it. And these proteins gather around those enemies, and it's like having a bunch of bees stuck to your skin. And eventually they make you pow! And we don't even have time to talk about it. And then there's toleration, and we're skipping that. Recognition, diversity, destruction, toleration, every one of them critically important for your immune system. And if you didn't have it, you'd be dead in a matter of minutes. So don't forget this. I gave you that sheet so you could be reminded what God has done to protect you by the death of thousands of cells in your body that are protecting you from getting killed by your enemies. And I close this lecture with a quote from Darwin's Black Box. The result of these cumulative efforts to investigate the cell, to investigate life at the molecular level, is a loud, clear, piercing cry of design. And he has it in italics with an exclamation point, so it's okay if I yelled. The result is so unambiguous and so significant that it must be ranked as one of the greatest achievements in the history of science. But he goes on to say, why isn't everybody rejoicing and just admitting that's the way it is? This was designed. And he closes by giving you an example. There's a bunch of scientists in a room, in an empty room, crawling around on the floor looking for something. There's an elephant in the middle of the room, and nobody sees it. And then he says this. The dilemma is that while if one side of the element is labeled intelligent design, the other side might be labeled God. And I'm going to tell you, I had a Harvard professor named Lewontin who has openly said, we will not let God's foot in the door. And what that means is you've excluded the only other possible explanation for complex things before you ever start. There's nothing right about that. I am against quoting Genesis 1 in a science classroom because the Bible is a book of revelation, not a science book. That's part of the reason scientists are so adamant about this. They don't want Bible thumpers coming into their science classrooms. I don't either. But have I used the Bible? I've used science class to talk about what's a reasonable explanation. And while you cannot investigate God with science ultimately because he's a spiritual being, he's not part of the material universe. That's why scientists hate it. If you can't give me a natural explanation, I don't want it. In fact, they'll say science doesn't allow it. It defines it out, so you've excluded the only other answer. And that's been done in Supreme Court cases. So I cannot go into a science classroom and teach the science like I've just shown you. And by the way, I don't yell like this in a chemistry class. But I do make it plain. And I make no bones about saying this points to a designer class, whether you see it or not. And I'm privileged to present to such a group as this evidence from the natural world that is shouting, this was designed. And the mind that designed it is incomprehensible and worthy of your praise and humble submission. And I thank you for sticking with me through almost 6 hours. Not quite. But you guys are tough, and I appreciate it. It means a lot to me when folks of all ages hang in there with me when we're talking about stuff like this, because it's not your normal stuff, is it? But is it amazing? It's amazing. And I have prayed to God to give me the strength to say it in a way that people cannot walk out of here without honoring our designer. So I hope that's the case for you. And thank you for coming, and we'll turn it back over. We'll see what questions you have.
Thank you, Dr. Payne.
This has got to come.
Briefly remind everyone that what we're going to do right now is we're going to take a very brief break, 2 minutes. That's 120 seconds. And then in that 2 minutes, we're going to collect up questions. And if you think of one and you'd like to write it out, please do so right now. Again, we ask you to put your first name and last initial on there so that if there's any clarification that we need in the Q&A, that we can ask you directly for a little bit more clarification. We recognize that there are going to be some people that need to exit out at this time. We want to remind everyone tomorrow morning at 9 a.m. and then at 10 o'clock, Brother Buddy Payne will be speaking at the Spring Street congregation and will be speaking at 9 o'clock on Have This Mind, the mind of Christ. And then at 10 o'clock, 2 disciples looking at Luke's extensive account in regards to the glory of the resurrection and its implications for us. So the 120 seconds start right now. Hand in those questions and we'll collect them.
And I need to get a drink of water. Testing, 1, 2, 3. Are we on? Okay, folks, thank you for being here for this. We'll have some fun, I hope. I haven't read these, so we'll just take them off the top. As far as I understand, without God, something coming from nothing is scientifically impossible. I'd say amen to that. So what is the atheist's explanation for how the protein-making process happened without protein? Well, did I say it? I read to you from Dawkins. He said any complex system can be broken down into enough simpler systems that could have happened by chance. Well, I mean, that's a possible explanation, but it's foolishness, folks. When you see interplaying complex systems that require the whole system to be functioning, now they would say to you, well, maybe it did something else for a while and then it got to where it did this. So there's stories out there, but there's no hard evidence for how single-celled organisms evolved into elephants over millions of years, or humans. That is not verified by the evidence. There's a bunch of stories about it. So they don't have a good answer. And why I emphasize protein making so much tonight is because it is one of the most massive things happening in your body all the time. And the process requires, could you answer for me that it required over 50 proteins to make one protein? As you copy the information, transcription, migration, translation, and then building the protein, that cannot happen without all the process. So there isn't a good answer. They make up stories. Believing in Jesus versus not being positive, will it help your immune system? Is that the key? Okay. At the end of Mr. Detmer's book, he deals with some of the things that are said about the immune system. Have you been told you need to get this so you'll boost your immune system? Okay. May I suggest to you, after what you learned tonight, that the immune system is incredibly complicated. Right? Would you agree? And you don't know half of it. It's way more complicated than I talked to you about. So if you think you can buy some kind of a vitamin that's going to boost your immune system and make some significant difference, you're dreaming, class. Generally healthful lifestyles, of course, will help because you've got to have the parts to make it work. But there aren't any miracle drugs or anything like that that are going to boost your immune system and help you be better. I think it's most of those, somebody's selling you something. So just be careful about that and be normal in terms of your diet to try to do healthy things, generally speaking. So, no, I don't think being positive, let me start over. Being positive is a very good thing for your overall health, no question about that. But to think that being positive is going to somehow boost your immune system in a specific way is probably also dreaming. But helping your overall health is not dreaming. So I would say just be careful about how you think things and say things like that. But I would say in life, you're better off to build on the good than you are on the evil. Isn't that right? We've got plenty of bad to talk about, but let's talk about good stuff. Do you know what the Bible says about that? Think on these things. What does he say? Things that are true, honest, lovely, of good report, healthy, strong. Don't let yourself be caught up in all the mess. And think about that, because that's unhealthy overall. So that's what I'd say to you. Do you believe that there's an increase in shingles as a result of the COVID vaccine? I don't know the answer to that. Shingles, of course, is a disease that can hang around in your body for a long time. You know that, right? Anybody know what that's kin to in a childhood disease? Chickenpox. So that can stay around in your system, and it does. And at certain stages of your life, it can get reactivated, and it becomes shingles. So I don't know that COVID affects that specifically, but I do know from what I've understood, COVID attacks weaknesses. So maybe that's one of them. I just don't know. I don't have the answer. So why or how does the body or cells attack itself in autoimmune disease like multiple sclerosis? That's a good question. And by the way, if you're interested, that book has a whole chapter on autoimmune diseases. And it's complicated. But basically the answer is this. If your immune system gets out of whack so that T cells start killing normal cells, that's autoimmune. That means you're killing yourself. B cells can do the same thing. Neutrophils can certainly do that if they get out of control. So if there's not enough apoptosis going on, you're going to get some pop some other way. Cells need to be killing themselves a lot. You know how once you attack an enemy, like when you've cut your thumb and it gets all healed up, why does it stop attacking things? Because there's nothing to attack. And so when a macrophage gets eating up all the stuff that's leftover garbage from the war, he just kills himself. And other macrophages eat him. And the neutrophils blow themselves up. You know, your inactive immune system kills itself rather quickly once the enemies are killed. So you fade out the system and you're back to normal. What you want in an immune system is homeostasis. Normal. It's kind of like us old folks. I like to sit in my easy chair and put my feet up and have nothing to do this particular night. One of the real advantages. All right, let's see here. Where are all the innate immunity cells made, and how do they get the enzymes inside of them at the same time? Also, how do the enzymes in the innate cells not dissolve the cells as soon as they are put in or activated? Boy, that's got a lot in it. Where are all the innate immune cells made? Well, you remember some of those cells that I described to you. The innate immune system is part of the overall building of proteins in your body. So there's a portion of your DNA that is coded for those particular types of cells. And when you make the proteins that make that up, then you've made that system. So that's part of your natural system. The adaptive system, the T and B cells, are all made in your stem cells. So it's very specialized. And I showed you that the DNA can use different parts and mix and mingle to make millions of different kinds of those B and T cells every day of your life. So innate's made by the normal system and B and T cells by an unusual system. And they have enzymes. Well, all of them do. There are enzymes everywhere. That's proteins, you remember? And so those are made the same way. And the enzymes, why do they not dissolve the cells as soon as they're out and are activated? Well, I think that's a misunderstanding, because enzymes are just specific proteins that help encourage things. How many debates have you had with atheists defending intelligent design, and how have they gone? I have had one formal 4-day debate. And I was just thinking about that tonight, because that was 1983 in Louisville, Kentucky. I debated a free thinker who was a chemistry professor at the University of Louisville for 4 nights. And how did it go? Well, I slaughtered him. But that's my opinion. No, frankly, he was not prepared for what I said. Because I don't take the normal view that some Bible believers take. I take a more scientific approach. And by the way, I'm an agnostic about some things. I just don't know the answers to some things. And I don't mind saying that. And I think you should be honest about things. I'll tell you one thing young people will see right through in a hurry is you try to fake answers when you don't know what you're talking about. Don't do that. And I will tell you, you can hurt the cause of belief in God more when you do stupid things and you don't know what you're talking about. It's better to defer to somebody else than to say something you don't know what you're talking about, because it hurts the case of believers. And I've had plenty of that in my life. And there's some folks I will not use their works because it's not right. Okay? So I only did that one formal debate, but I've had lots of lectures like this where we did Q&A and professors would stand up and we'd argue about things. So I've done plenty of that. Are autoimmune diseases a product of a killer T cell sneaking up through Murder University, or the bad code in a protein chain, or a lack of the B cell making antibodies? Well, autoimmune diseases come about when the system quit working properly. Do design systems ever break? Yes, they do. And just because something breaks and isn't working properly anymore doesn't mean it wasn't designed in the first place, does it? I mean, were cars designed? Do you ever have to have them fixed? And do they sometimes quit working properly? They wear out. Well, your body wears out too, and you mutate. And things happen chemically that mess up. So that just happens. It's part of life. And by the way, once, I will say this again, this is not a scientific answer, but once sin entered the world, you're not here for eternity. You're going to die. Okay? And to die, something goes wrong. So, no, it doesn't have to be a specific product killer T cell that snuck through the thymus. But it might be something broke down in the process where a T killer cell that was going to do this ends up doing that because it mutated or something. It's complicated. Why was the COVID-19 vaccine a mistake, as you previously stated? Are people negatively affected by it? Well, please don't leave here saying I said that COVID-19 vaccine was a mistake. What I said was I think they put it as a necessity for humans all over the world too quickly. I'm not opposed to trying this out, but you need to do careful testing when you're doing something brand new. And you're going to impose it on people as if they're bad guys if they don't take it. People lost their jobs over this. My son-in-law lost his job as a fantastic engineer for a company because he refused to take the vaccine. He felt like it was not good for his system. And they fired him. Now and it's based on less than careful analysis, in my opinion. I'm not critical of anybody that chose to take it. We were scared to death, weren't we? People were dying by the millions. And everybody was saying, if you don't do something, you're going to hurt grandma, right? And you're not being godly because you don't love your neighbor, that kind of stuff. So I get it. And it's a very personal thing. So no, I'm not saying it was a mistake in that sense. I think the mistake was pushing it too fast, too hard on too many people and forcing it. That's my opinion. Did the mask we were required to wear do anything to prevent viral particles from being inhaled? And I would say for that class, you look it up for yourself. The evidence is overwhelming that masks like the ones we wore are useless. I don't think there's any question. The evidence from science is that was a ridiculous requirement. In terms of reality, I mean, even if you use a really heavy mask that they use in hospitals, they don't even keep all that stuff out. And the stuff that we use, you know, you put this stuff up, in the first place you didn't do it right. 90% of the people wore stupid masks, and they did it in stupid ways, and they were rubbing themselves all the time. That isn't doing anything except helping spread things worse. That's my opinion. And I think it's based on solid science, that is. You go look for yourself. That's my opinion. What is your view on what the world calls global warming? Well, we're really getting off now, aren't we? I don't think anybody can deny that there's global warming, just from the facts that generally temperature's going up. But it's not going up that much, folks. And how much more is it going to go up? Nobody knows that for sure. The issue is, how much of that is the responsibility of human activity? That's the question. That is not a well-established thing, in my opinion. So is it a normal cycle that's taking place? You do know, don't you, there's good solid evidence historically the temperature's been a lot higher in the past. And we didn't all die. Neither did all the animals. You would think the world's coming to an end because we got too much carbon O2, CO2. I don't think so. How does the immune system affect autoimmune diseases? Well, it's a disorder of the immune system to have an autoimmune disease. Something is not working properly. So that's like anything else in your body that doesn't work properly. So let's see what else we got here. I think that's it. You got one more? Please explain why irreducible complexity is an important counter to the evolution from the simple to the complex. Okay. For that, I'll refer you to Michael Behe's book, Darwin's Black Box, because he's the first one to introduce this idea of irreducible complexity. I've been saying the same thing without using those words. What it means is there's some systems where every piece is needed or it doesn't work. Remember I told you the blood clotting thing? That's in this book. Blood clotting is a cascade of reactions. If this one reaction out of that whole cascade doesn't work properly, your blood doesn't clot. Right? That's a hemophiliac. That's a system that is irreducibly complex because you have to have it all to guide it and carefully protect you. And by the way, I didn't mention this. The whole cascade that causes you to clot then has to stop and reverse itself or you will clot yourself to death. Are you aware of that? Clotting is your best friend when it stops the blood flow. It's your worst enemy when it keeps clotting and goes into your bloodstream and blocks up your heart and kills you, or goes to your brain and causes a stroke. That's an irreducibly complex system. It is amazingly balanced. And how in the world did that happen? Because this happened billions of years ago, and then another million years this happened, and then over time this was doing one thing and it quit doing that and did something else and added to the cascade. In the meantime, you're dead. Or anything using that was trying to develop it doesn't work. That's the idea. And he illustrates that by several amazing examples, not the least of which is blood clotting. So, that's that. Thank you, class. You were wonderful.
Hey, stay right there for 1 moment.
Okay.
There may be some folks that may not quite be ready for that test tomorrow morning that you were talking about.
Right.
There may be some who need a little bit of extra credit. So those of you who were here last night, if you remember, Dr. Payne
That's
asked
right.
a question.
That's right. I forgot to ask you.
He would give us a little bit of extra credit. So if
Right.
you want to repose your question.
My question, remember we were talking about how important the moon is? Earth has how many moons? One. And it's humongous. So I asked you about Pluto, and she's asking her telephone. How many moons does Pluto have? Anybody look it up? Yeah, tell me. Nope, that's close. 5. Little tiny Pluto has 5 moons. Earth is a lot bigger than Pluto. It has 1 moon. That's no accident, ladies and gentlemen. That moon has a critically important role to play in your being here. If we didn't have that moon functioning like it does, you wouldn't be here. That's another one of those finely tuned things about nature. Pluto has 5 moons, and one of the reasons they were arguing about whether it's a planet or not is because one of those moons is almost as big as the planet Pluto. So which one is the planet? Or are they both just big old rocks? Well, the Pluto does circumnavigate our sun. That helps. But so does that rock going around it. So which one's going around which is the question, one of them. Who can name the moons of Pluto? Well, isn't that something you carry around in your head? Can anybody name one of them? Huh? Yeah, I think that's right. One of them's named Styx. S-T-Y-X. All right, that's your next assignment. You got to name them. But here's the other interesting thing you need to do. There was a famous NASA project called New Horizons. Write it down. New Horizons. You need to go look it up and follow it. That was a project to send a spaceship from Cape Canaveral in Florida to Pluto. It left, and it took it 10 years to get to Pluto. And class, NASA had mapped out the entire 10-year trip with an itinerary ahead of time. And one of the steps of the itinerary was to send that ship close enough to Jupiter that it would go around Jupiter and whip off much faster on its trip to Pluto by the gravitational force we've learned how to manage. Because Jupiter's so huge, you can use the force of gravity to cause a whipping effect and make you go faster. But think about it. Our universe and our solar system in particular is so well designed that NASA can plan a 10-year trip, the whole trip, ahead of time. Is that amazing? That means we know enough about the order of our solar system to predict what's going to happen ahead of time and use the things we've learned, like electronics and how to send signals over millions of miles and how to use gravity to our benefit, to send a ship to Pluto. And did it get there? Yes! So you can go look at that whole thing. They tell you the whole story. And then after it circled Pluto and made the most beautiful pictures of Pluto we've ever had, and a bunch of moons, it sent it on out to the Kuiper Belt beyond that, and now it's studying little chunks of rock out there, trying to figure out how those got there. And of course, you know the whole thing, in their view, is evolutionary. How did this evolve? And I asked somebody, how did that ship get there, and how did that happen? That was design, class. And it was designed based on what our human minds have been able to learn about the properties of nature that are so regular we can predict ahead. And you know, don't you? You can map where the next moon, what? Eclipse is going to be on Earth at any instant. Because it's so regular. We also know how it's changing. That's enough.
Would you help me thank Dr. Payne?
Thank you.
Thanks everyone for being here tonight. Thanks for those who are joining us on the live stream. We understand we have an entire firehouse that is joining us tonight. A bunch of EMTs that are all sitting around, and we're very much interested
Here, you
in
take
hearing
this
about
one,
the immune system. And all the other firefighters said, well, hey, if we don't get a call, we'll sit and we'll watch it too. Thanks for joining us on the live stream. And we look forward to seeing any and all of you join us tomorrow at 9 a.m. Dr. Payne will be speaking with you. Have a good night. Drive safely. We'll see you tomorrow morning.
All right, here's this.
Thank you.
Thank you.
Oh, sorry.